Okay, welcome to the introduction to programming class. Okay, so we considered several variable types before the middle term. So we considered some ordinary variables like integers, floats, or strings. And then we considered a new type of the variables, which is called the list variable. So that is kind of container which can hold every type of variables which we considered or which we will consider. Okay. And then today we will consider something called functions, which is one of the key components in programming. So please listen carefully regarding this. So the function is a self-contained named block of statements which are reusable, meaning we want to use this block of codes, okay, to perform a single specific task, and we want to use that code function at several places. That's what I mean by reusable. Okay, and it is a named block of codes. That means I will provide certain name to these statements so that I can call that function name several times and as many times as I want, okay, at several places. And this block should be self-contained so that if certain variables are needed, for example, those variables must be defined somehow within this definition of a function. And you already observed, actually you already experienced several functions. For example, you called the print function on the first day, and then we also considered the input or length function. Sometimes we could convert one type of the variable to another by calling, say, str function or list function, or sometimes we could call float or integer functions. Right? And instead of just relying on these built-in tools, we can build our own custom functions to automate certain specific calculations or certain logic. And then why do we use this function? First of all, the reusability. Meaning, for a certain task which is required to repeatedly used in several places, then I don't want to repeat myself. Okay, and instead of copying and paste several lines of code, I want to combine them, okay, and then define them as a function so that whenever needed, I want to call the name of that block of statements. And if I have a function, then usually it is simpler so that the readability becomes better. And depending on the situation, but if I look at the name of the function, for example, if the name of the function is, say, calculate a loss, then probably if the name is well defined, then probably that block of codes will calculate the loss of a certain operation. So that whenever I read this name of the function, then I can predict, okay, what that block of code will do. Okay, so that kind of readability and abstraction will be improved. And if I need to modify certain part of the code, then if I use a function, then you can just go to that place where that statements in the function are defined, and then I can modify that part only. But if I copy and paste that code at several times, then I need to find all the occurrences of those statements, and then I need to modify the values or statements. So the maintainability will be also improved if I have the function usage. And of course, this function may have some disadvantages, so that on next week, probably next Monday or Tuesday, we will develop something better than this function. Okay, so we will see several functions this week, and then you might feel due to this function will be better than ordinary statements. But function has some demerits as well. So to overcome that kind of disadvantages, we will develop something better, slightly better, next week. Anyway, these are the benefits of using the function. So for example, suppose that I want to print several statements, say system update, and say I want to print, say, name of the student like Joseph, and then I want to print some statement. And then for some other student, say someone, I want to print out something as well. And then for another student, say Hyan, I want to print something for her. Okay? So this, for each student, I'm printing some statements. So instead of copy those printed line and paste at 3 different places, I can define one function. Okay? So I can define something. We will consider how to define a function in a moment. So somehow I will define a function. And then I can provide certain information for each task. Say I can provide the name of the student. Then, depending on this user's information, certain output can be generated. But in this case, the code becomes simpler. Simpler in the sense that if I need to change, for example, this update to, say, update with lowercase u, instead of uppercase u, if I do not use a function, then I need to go each place where this function and the update word is used, and I need to correct them for each occurrence. But in case of the function, I can go to the definition and then change this uppercase u just once, then the effect can be obtained whenever you call this function. Okay? And by calling this function as, say, 3 times, then I can easily understand the structure of this code. But without the function, all I see is just some statements, some long statements. So I need to check carefully to understand the meaning of the code in that case. But with this lower code, with this usage of the function, the readability is improved. But anyway, the point is that if you want to repeat a certain task more than once, then probably it will be better to define a function. So the print function is, and we've previously considered one function called print. We considered this function on the first day, and this print function is slightly different from other functions in the sense that the other functions, for example, for any the custom-made functions, we will define with some function with predefined number of parameters. So when I define a function, I will define that, this function will accept say 5 values from the user or 10 values from the user. Only a finitely many number of the values can be given from the user to the function. But in case of print function, it can receive any number of values from the user. That is one special character of the print function. And this function, print, receives some values. Okay, that will be called the values for certain objects. Okay, so you can provide certain float number, integer value, or several strings. You can provide several objects. And then additionally, you can provide certain value for SCP, separator parameter. Okay? If you do not provide any value for that parameter, then between any two adjacent objects, the print will add one single space, right, as a separator. But you can change the value of that separator. That's what you did that's what we checked in the middle term. And also, I can provide the value for the end parameter. So instead of using the new line character, I can provide any symbol or any character, and that can be used as the end parameter, right? So we can provide the information for those parameters, and whatever you give, those information will be displayed on your screen. Oh, and actually, there are some more additional parameters for the print. Okay, and if you do not want to see the output on your screen, we can change that as well. And we will study that probably sometime this week. We will change that. Okay, so instead of displaying the value of the variable on your screen, we can generate that output to somewhere else. Okay, so there are some more parameters, but so far we could just provide the values for certain objects, or we can provide the values for the separator or end parameters. But this function print does not return anything, right? In other words, it returns none, nothing. Okay, so if you assign the result of this print function on certain variable, then that variable contains nothing. Or in other words, that variable has a none as its value. So here are some examples. So I have the variable myString, okay? And if I call stl of 100, then this integer value 100 will be saved as the character string of 100. So when I printed this, then the type conversion result with 100 will be displayed. And if I call print with hello students, then hello students will be displayed on the screen when this right-hand side is evaluated. Okay, but this function does not return anything. So hello students will be displayed on the screen, but since this function does not return anything, or in other words, this function returns none, when you try to assign the result onto a certain variable, the captured value receives nothing. So if you try to display the value of the variable on the screen, the Python says none, okay, for the value of the variable, because the print function does not return anything. Okay. So none means mathematically an empty set. So that is what is returned by the print function. So these are the behavior of the print function. It may receive some argument like text string, then that text string will be displayed on the screen, and And that's the role of the print function. But that function, print function, does not return anything. Okay? The displaying the values of the objects is what print function is doing, but that is not the output of the print function. Okay? So please distinguish this result on the display from the return value of the print function. Question? Now, that's what we considered with the print function. In case of the input function, the behavior was slightly different from that of the print function. In case of the print function, I could provide as many values of the variables as possible, as I want. But in case of the input function, I could provide up to one value, right? In case of the print, I could provide 2 or 3 or even 10 values of the objects. But in case of the input, you provide nothing, either nothing or one text string, right? The type of the variable is fixed. You need to provide certain text string in case of the input function, right? So in case of input function, you can provide, okay, either you do not provide anything, or you could provide one text string called a prompt. Then this text prompt will be displayed on the screen so that the user can get some information regarding what he or she needs to type, right, from this prompt. And then when the user types something and then hit the enter key, then whatever is typed will be returned by this input function, right? It returns a certain text string. So if there is no receiver, okay, then the information from the user will be discarded. It will be lost. So whenever you use the input function, probably the usage of the input function will be certain variable equals to input with possibly one prompt. That will be the format, the syntax of the usage of the input function. So when I compare this print and input, the number of values the user provide will be different. In the print function, the number is not fixed. In case of the input, you can provide up to one value, right? And regarding the type of the variables, in case of the print, you can provide any type of the variable, the variables of any type, say integers, floats, or text string. But in case of the input function, the type is fixed, right? And in case of the print, it does not return anything, but in case of input, it returns as a text string. So these are some differences between these two. So in case of the input function, if you want to call this input function, probably you need to provide a certain prompt so that the user can provide appropriate information. Then when the user types something, that something must be received by the program, and the program must use a certain assignment format so that this current year variable receives the information from the user. Okay? The one problem with this current year variable is that whatever the user types, this input function will return that information as text string. So the current year in this form cannot be added by 1. That numeric operation can be performed only when this current year is a numeric value. But if in this case, in the current code, the current year is in the format of text string. So the addition by 1 is not allowed. So when you perform that operation, you get an error message. So if you expect certain integer valued input from the user, then when the input function receives that information from the user, you need to convert that value to an integer by calling int function. Then this input function will return certain value, and then that value will be converted to an integer value. But of course, this code is not that safe, because if the user types some information in, say, a float type, or if the user provides some text string, then the conversion by int function will cause an error. So before you call this integer function, it might be better, it might be safer to check whether that information is really an integer valued. Okay. Then if the value from the user is actually an integer valued, then you can call int function to convert that information to integer valued. And then you can perform any numeric operation like addition by 50. Okay. So this code works only when the user enters, say, 20 or 5. So if the user types the kind of integer valued information, then this int function will convert that to appropriate integer value. But if the user types some decimal point number, say 3.14, then that conversion with int function will fail, and Python will give you some error message. Right? So that's what we studied so far. Now, a custom function, okay, can be constructed, but when I construct a function, okay, in Python, we have two steps. So the definition of a function can be performed first, okay? So certain function must be defined. But when I define a function, that is different from execution of the function. When I say a definition, that means certain task will be declared. Okay, certain tasks, certain code statements will be declared by the user. Okay, and that will be called definition. But in Python, when certain function is defined, the Python interpreter will check if each expression is correct. Okay, this Python interpreter will check whether that syntax is correct. But it does not actually run the code yet. If you need to execute certain task that this function is supposed to do, you need to call its name. So in Python, the definition and call are two different tasks. Okay? So in case of the function definition, this is where you write the internal logic and steps you want to happen. Okay? And it is like writing a recipe in a cookbook. But when you write a recipe in a cookbook, it does not actually make any food, right? So the code is not executed yet. And if you want to execute certain task, you need to call the function. You need to call the name of the function. Then when the name of the function is called, then the task defined in the definition of the function will be executed line by line from the top to the bottom. Okay? So if you do not make a call, then no part of the code, no part of the function will be executed. So this is an example. If my code consists of one print line, here is the definition of a function. I will explain this definition in a moment in the next slide. And then I have another print function. And then if I type the name of the function followed by parenthesis, then this one actually calls the function. So if I call the function, okay, even though the definition of a function is defined above here, Python interpreter will run this print line. It will skip this comment. When the Python interpreter sees the definition of a function, it will only check whether the syntax, the grammar, is correct. So if the grammar is fine, Python interpreter just skips this part and then executes next function call of print. And then when you actually call the function here, at that point, Python interpreter will execute each line inside this definition of a function. So that's why you see this result of first print command. And then right after that, you do not see the output of the function, even though in the code, you have the definition of a function there that is given. This definition just follows this first print line. But those statements inside the definition of a function are not executed yet. So once you see the output of the first print line, what you see is the result of the second print line. It does not show this part. Okay? So you see step 1 and step 2. And then the code calls the function simulation header. At that point, the Python interpreter will execute the lines defined in the code, in the function. So at that point, these three statements inside the function will be executed. And then you go, so once it completes this task, you go back to the stream, okay? And then we'll execute the last print line. So once this function generates 3 lines of output, you see the result, step 3 result. Okay? So this is the way, okay, this is the order how each code of the line, each line of the code works. Okay? So step 1 and step 2 are the statements which we considered, and then you go into the function, and then once all 3 statements are completed, you go out of the function and execute next line. Okay? So this is the order of operations. Okay, one by one from the top to bottom, but whenever you see the definition of a function, it first skips it. But when you call the name of the function, at that point you go inside. So the function definition, that just corresponds to writing down a recipe in a cookbook, but it does not run the code yet. But if you call the function by calling the name of the function, like print function or input function, we just need to call this print or input with a parenthesis. Then that will execute each line defined in the body of the function. So in order to define a function, the first expression you need to use is the word def. So if you want to define a function, the line must start with the keyword def, followed by the name of the function. And for naming this function, okay, this exact same rule as the variable names will be applied. Meaning you can use a combination of letters, numbers, or underscore, but the function name cannot start with a digit. Okay, your function name start with either underscore or letters. And of course, the lowercase and uppercase are different expressions. So you provide the name of the function followed by parentheses. And inside the parentheses, we need to provide certain values, and I will explain that later. And then right after this parenthesis, you need to put colon. That will say that, okay, that is the end of the first line of the definition of a function. After that colon, okay, that colon will be followed by several statements, and these statements, okay, must be indented. So if you want your function to do something, okay, that something must be declared or with some indented statements. Okay. Usually, they use only 4 spaces for the indentation, and you describe the actions that this function is expected to do. Okay. And in some other languages, they define this block of statements with some other symbols, like in C or C++, they use curly braces, but in Python, this indentation is the only way to define the indented block of statements. Okay, no other symbols are used. And yes, so when you define a function, these indented lines are saved in memory for later, okay? But they are not executed at that moment. So Python interpreter will check only the grammar, the syntax of the code. So if the expressions are correct in terms of the grammar, then Python does not complain at that point. Okay? Even when the grammar of the expressions is correct, sometimes it might cause some problem. Okay? So the execution, okay, the error from the execution is different from the error from the syntax checking. So when the function is defined, the interpreter will check only the syntax. As long as the syntax is fine, the interpreter will skip, okay? So we will see some examples. So here is the format of the definition. So the first word will be always the def, followed by the name of the function, followed by parenthesis and colon. Right after this colon, you need to provide some indented statements. Okay, so those indented statements will be the action that this action, okay, that this function is called. That function will perform when this is called. So in this case, this function will print, okay, 3 times with appropriate text strings. Okay, but when I run this code, my code consists of one print line and one definition of a function. As I said, if I want to call a function, okay, if I want to execute those indented statements, I need to call the function. I need to call the name of the function with parentheses. But this code does not call that function. So when I execute this code, okay, my Python interpreter will just check the grammar, okay, of this function, and then it will execute only this single print line. So if I run the code, only this line will be displayed on the screen, but that function, okay, is not run. Okay, because I didn't call the function yet. Okay? And okay, so when I name a function, you need to follow the same rule as the names of the variables. So the first letter must be an underscore or a letter, and you can combine some letters and numeric values and or underscore, but the first letter must be either a letter or underscore. For the remaining, you can combine letters, numeric integers, and underscore. Of course, the reserved words like def, if, while, for, these words cannot be used as the names of the functions. For example, this is one of the proper names, okay? The first letter is a C, and the names consist of the underscore and letters and in some numeric integers, right? The name of the function may start with an underscore. Okay, that is allowed, but usually the function name starting with underscore is used for some system. So unless you are not a system administration, okay, usually the name of the function will start with some alphabets. Okay, but you can start with underscore. That is allowed. But if you name the function with some digit or some keyword, Python will complain. Okay? So those are not allowed in Python. In some other programming languages, you can override, say, while may be accepted in some other languages. Okay? There are some languages which allow that, but not in Python. In Python, using the reserved expressions like while or for as the name of the function, that is not allowed. Okay, and if you try to do that, the Python will complain with syntax error. Okay, so using reserved words is not allowed in Python. And usually, similarly to the names of the variables, usually people start the name of the function with lowercase alphabets. Okay? We will study something called a class next week, and for the name of the class, it will start with uppercase letter. But for the name of the functions, we usually start with a lowercase letters. Okay, that is just a common style. Okay, if you use uppercase letter as the first letter, Python does not complain, and it is not wrong. Okay, it is not wrong, but many people in Python community use the lowercase as the first letter of the name of the function, and usually keep names short but meaningful. Good naming is very informative. Okay, so for example, if I just use, say, function A, so if I define a function with name A, this name is not that productive or informative, right? So even though it is short, but it is not that meaningful. So this A may not be a good name as the name of the function. Anyway, and similarly to the variable names, usually we have two types, the snake case type and camel case type. In case of a snake case type, all the words, okay, are combined with underscores. And all the words are written in lower cases. And in case of the camel case, we do not use the underscores, but we combine each word, okay? And when you combine two words, the first letter of the second word will be displayed in the uppercase, and all the other letters will be written in lower cases. This camel case may be common in some other languages. In Python community, people prefer snake case style. It is not mandatory, okay? Both expressions are allowed. Even some expressions like, say, apple, banana, even though it is not camel case, this apple, banana with uppercase A and B is allowed as the name of the function in Python. That is fine, okay? Python does not complain with this. But as I said, even though it is allowed, okay, not many people are using that style. Okay? Anyway, it is not mandatory, but people usually prefer snake case in Python community. Okay? That, as I said, what is preferred. So, as an example, if you name the function like this, snake case style, then there is one fine name, and here is another nice name. Even though the Python prefers the former, okay, the latter is also fine in Python community, and both are fine. But anyway, these are the definitions. If you want to execute corresponding tasks, you need to call them. You need to call the names of the function followed by the parentheses. When you call these functions, the statements indented will be executed line by line. Usually, all the indented statements will be executed. We will see on exceptional situation in a moment. Questions? So as I said, if you want to execute the statements, the indented statements corresponding to a certain function, you need to call the function. And when I say the calling a function, you need to type the name of the function, okay, followed by the parentheses. Okay. You do not put colon, okay, when you call the name of the function. Okay. And inside the parentheses, usually you provide certain information from the user. But at this point, we didn't define a function to receive any information from the user yet. So at this point, user provides nothing. And even in that case, when you call a function, you need to type the name of the function followed by the parenthesis. Okay? So you always put the parenthesis, even though it contains nothing. Okay, so here is an example. So this line defines the name of the function, run BLL pipeline. That function consists of two indented statements. But this definition does not execute those two lines yet. Okay? So the Python interpreter will check whether this syntax is correct. And if the syntax is correct, it will check the next line. The next line is to call this print function. So print, the name of the function, is typed with the parenthesis. So that will call the print function, which is defined somewhere in the system. Okay, we do not know the definition of the print, right? But that expression, the name of the function followed by the parenthesis, will call that function with appropriate information from the user. That information will be given to the function print, and print will do certain task. Okay? So, as far as I know, as we know, that statement, the text string will be displayed on the screen. And then we call the function. So I just type the name of the function followed by the parenthesis. That will execute these two lines in the definition of a function. So at that point, these two lines, okay, will be generated. So those are the output from this function, run BLL pipeline. So right after the result of the first print, two print statements inside this function will be executed. And then right after that, you get the output from this print that will be displayed here. Okay. So the order of the output is different from the order of the code. Okay, in the code, you have the definition of a function, then we have a print line, and then function call, and then another print line. Okay? So as long as this code follows the syntax of the Python, it does not execute any statement defined in the function. It does not give any warning or error message. Okay. So when Python encounters a function call, okay, when you see a function call, Python will pause for a second, and then it goes inside the function. It goes to the definition of a function, and then check the indented statements one by one, okay, from the top to the bottom. Okay, the interpreter will leap to the physical location in memory where the function is defined, and then executes those indented statements one by one from top to bottom. Once the final indented line is executed, it goes back to the exact line, okay, right below the original function call, and then resumes the main script. Okay? So when I have this code, my code first defines this function check status. Okay? And then, so Python interpreter will check the grammar of that definition. And if the grammar is fine, my Python interpreter will execute this print so that this number one output is generated on the display. And then Python interpreter will execute next print so that number 2 statement is displayed. And then you have the call, function call. At that point, my Python interpreter will go inside of this and execute this print so that this is displayed on the screen. Once that is done, you go outside of the function and then you go back to the original place and resume the executing the statements in the code. I mean, right after this, you go to the next unindented line to generate the outputs corresponding to these print lines. Okay? Now, if you have writing the bulk of your active operation directly on the left margin causes messy, unorganized scripts that are very difficult to debug or trace or understand. If I have a single function, or if you have 2 functions, okay, and if your code consists of, say, tens of lines, that is fine. But usual code like the Google Chrome, that consists of more than millions of lines. Okay? It is very difficult to trace all those functions. Okay? So, and there may be thousands of functions, okay, in your code. And in that case, it is very difficult to trace all these codes. So, usually, a professional programming standard is to wrap the core executing logic of your scripts inside a single dedicated starting function. Okay? So, in many programming languages, we consider this strategy. We consider this situation. Okay? So, given many functions, then among these functions, which function will trigger first? And in many programming languages, we design a central coordinate function named main, and the sole responsibility of main is to call and manage all other functions, okay, defined in the main function. So the structure should be the definition of several functions you create, and then you define one main function, and inside this main function, okay, you organize these steps. If certain functions, say predefined functions like print or input are needed, you can write them there. If you need to call certain functions to define your own creation, you can provide the names of the functions at some appropriate places. Okay? So you define a function in certain order. So this main function will declare the correct order of operations. And then at the end, you just call this single function main. You do not call any other functions, but just main. Then main will execute these lines one by one. Okay? Anyway, that will be the ordinary structure used in many other languages. Not only the Python, but C or some other languages, they have the same structure, similar structure. Now, then do I have to use the main function in Python? No. You don't have to. As we observed, we could build a code, okay? We could build a code without using the main function. But but many people in Python community, as well as some other communities in programming world, in say C, Fortran, or some other languages, they usually build some big code with this main function inside. Okay? So even though you do not use the main function, at least you need to understand the structure of the code when this main function is used. So it is recommended to use the main function when you make a code. Okay? So in my class, I will frequently use this main function. So I will build several functions, and then I will arrange those functions within this main function, and at the end, I will call that main function. So that's how I will do in this class, and that is my suggestion. When Python reads a function definition, it simply memorizes, okay, that blueprint, and it does not execute any part of the code yet. Okay? But when you call that function, Python interpreter will execute the statements inside of this blueprint one by one. So when I have the definitions of several functions in the code, as long as those definitions follow the grammar correctly, then Python interpreter will skip those definitions. Okay? Python interpreter will just memorize the expected behaviors of those functions. And then when I call the function, main function, then it will execute the statements defined in the blueprint. So if I call the main function, at that point, this Python interpreter will go inside of that function definition and then will run this code one by one. Now, in this case, the main function consists of a single line. So that print function will be executed. But when you call the, sorry, not this one. Sorry. The main function consists of two lines. So it will just it will display some statements on the screen. After that, it will call this function. And at that point, so when I call this main function, it goes inside the main and then run print function, and then it will try to run the check hardware function. And at that point, Python interpreter will go inside of this check hardware function, and then it will try to run this code. Okay? So when you run this code, you will see the output from the first line of the main function first, and then that is followed by the statement generated by the print function of the check hardware function. Okay, that's how the output is generated in this code. So when I call the function main, at that point, main function must be defined somewhere in the memory. Okay, so at that point, the main function must be defined somewhere in the memory. I do not check the contents of the main function yet. Okay, inside the main function calls two functions, print function and check hardware function. I do not check the definitions of those two functions yet. When I call main function, okay, I just check whether main function is defined or not. Okay? So At that point, so you need to define the main function just before you call the main function. And then if you go inside of the main function, so when you call the main function, you will go inside the main function and execute line by line. When you actually execute those lines, at that point, the functions executed inside the main function must be defined before they are declared. But when I call this function, those two functions, main and check hardware, are already defined. So when I call the main function was defined, okay? And then when I go inside the main function, that you go inside only right after you call that main function, and that point is, if that function is called after the definition of check hardware function. So at that point, we already have the blueprint for the check hardware function. So when I call the check hardware function inside the main function, there's no problem with it. Okay. Here's what I mean. So suppose that I have the definition of a function A somewhere. And then if I want to define the function B, and if my function B calls the function A, okay, if that's the structure, then when I have this code, the definition of the function B, and then if I call that function, then I have a problem, because at that point, okay, when I call that function, my Python interpreter will go inside of the function body, and at that point, function A will be executed, but with this structure, the definition of A is not given yet. So if I provide the definition of A here with some statements, then this code does not work. Because at this point, when this line is executed, Python interpreter does not have any idea of the function A. But if I have the definition of A here and definition of B here, and then if I call the function B here, then there is no problem. Now, even with this structure, if I call function B down here, then there is no problem. Because when I call this function B, that is given after the definition of a function A. Right? So in that case, there is no problem. So if I have, So if I have many functions, say if I have hundreds of functions, it is very difficult to trace all the contents of functions. So that's why people are using the main function. So you have the definition of many functions in whatever order. And then they define main function with some function calling. You may call function A, you may call function B or C or whatever. And then if you call main function, you don't have to worry about the contents of these functions or their ordering. So that's why you define many functions, as many functions as you want in any order. Okay? And then you provide appropriate description of these statements within the main function. Then, as long as these functions are somewhere defined, then when you call the main function, there won't be any problem. Okay? That's why many people are using this main function. And when you call this main function, among these, you can rearrange these functions in any order. So as you observed in the previous code, you can even put the main function at the top of the code, and then you can define all the required functions below. But as long as those are provided before you call the main function, there is no problem. So this is one way to organize your code, and that is what we are going to use in our class. So we will call this main function. We will define the main function to organize the functions defined in your code. And that will be useful, especially when you have some collaboration with other friends. Okay? And when you call the main function, you just type main followed by the parenthesis without anything inside. Okay? So usually at this point, later I can change that statement, but at this point, as of today, main function takes no argument, meaning you do not put any expression inside the parenthesis yet. Okay? Later, we can change that information. When you get experienced, okay, you may provide some arguments inside even the main function. But as of today, today, okay, the main function takes no arguments from the user. And at this point, the main function does not return any value. So you just type MAIN with parentheses. Okay? And as long as you have all the required definitions of the functions somewhere before you call the main function, you can rearrange all those definitions of the functions, including the definition of a main function, in any order. And yes, so you can put the definitions of the functions in any order, and as long as these definitions of the functions follow the grammar of the Python, the interpreter does not give any error message. So as long as the syntax is fine, it does not check the logic. Okay? It does not check the logic. I mean, as an example, if I have, say, A equals B plus 1, that statement will be true if B is either an integer or a float number. But that expression will be an error if B is a text string. Okay? Right? So this statement may be true or may be false. But if the statement, if B is an integer, that statement will be fine. Right? So in terms of the grammar itself, that grammar is fine. Right? So if you see a statement like that, Python interpreter will skip it, because that expression may be true, okay, if B is an integer or a float number. So, and as long as the required definitions of functions are defined before those functions are called, okay, you can arrange these functions in any order. That is a convenient tool in Python. Okay, and then, okay, so since I don't have time, so let's take a break for 10 minutes, and then let me resume, okay, in 10 minutes. And in the meantime, please check the attendance. Okay, see you in 10 minutes. Okay, so we were talking about the definition of a function and how to call. Now, from now on, okay, I will talk about a few things which are very important and you need to be careful. First, just like the mutability is a fundamental trait of every data type, there is something called a namespace you need to remember. That is a fundamental property of every object in Python. In other words, when you define a function or variable, for each variable or function, something called namespace is combined. Okay? So an object name, when I say a namespace, okay, it is the boundary or the reason. So it is the exact boundary or a reason of code from which that object can be seen and accessed. Okay? So if I define a variable, then there will be the corresponding namespace. So this namespace is a certain reason. And only within that reason, I can call that variable. Okay? So for example, you know my name, so you can call my name here within this class. But if I go outside, okay, nobody knows my name. Right? So if I go outside the university, no one knows me, right? So only within the class or within the school, students can understand my name. Okay? So, it's very similar. So within certain reason, okay, called the namespace, we can see the value of the variable and we can access that value of a certain variable. Okay? And the same thing for the function. So for a certain function, that function is recognized only within certain reason. Okay? And that region is called the namespace. In computer science, the term scope and namespace are effectively two sides of the same coin. When I say the scope defines where you can use the variables including functions. And namespace is the system container holding that name. So you can interchange these two terms in our class. And any variable initialized inside the specific function body belongs to that function's local namespace. Meaning, okay, I will show the example in a moment. So suppose that I have the function called main. Within this main function, I define one variable. Then within this the main function, the scope of this variable is limited to this main function. In other words, I can use that variable within this main function, but you cannot use that variable outside the main function. So when I define the main function, and then if I call the main function, then Python interpreter will go inside the main function and then assign certain value to this variable, and you can even access that value so that we can use that value inside the print function. So these two statements are fine. There is no problem with this. Okay? So after I call the main function, I can call the print function. That is fine. If I try to access the variable outside the main function, I have a problem. At that point, Python will give you some error message. So the execution of the print inside of the main function is fine. Or even the print function without accessing that variable outside the main function is also fine. But if you try to access that variable outside the main function, at that point, when you evaluate that variable, you get an error message. You get an error because that variable is not seen outside the main variable. Okay? So, if you define any variable within a certain function, that variable will exist only within that function. So when I call that main function in your memory, so there is some reason for the main function in the memory. Within this main function, my framework tag variable will be created. And then the program assigns BLL v2 value to this variable. Once you complete all the tasks defined in this main function, your Python code will erase everything. So once this main function is called, and then when you execute this print line, at that point, all the variables defined inside the main function will be erased from the memory. So when you try to access that variable at some other point, we got a problem because that variable does not exist. So that's the situation here. In other words, this framework tag variable is defined, or it can be accessed only within the main function. When the third line of the main function is completed, at that point, so when you go out of the main function, all the predefined variables will be erased. So please be careful when you use these variables. So that's the situation of the Python. So if some variable is defined inside, say, for example, main function, the scope of the variable is only to the main function. If you have another function, say train model function, for example, and if you try to use the variable defined the main function, okay, within this train model, then we have a problem, and vice versa. If some function, say train model, has a certain variable in it, and then if you try to access that variable outside of the main train model function, then we have a problem. So here is the situation. So suppose that I have two functions, the run gradient descent function and main function. So in run gradient descent, I have a variable named epoch count with the value 500. In the main function, I have the same variable with a different value. There is no conflict with these two variable names. So to the human beings, okay, you have two variables under the same name, but inside the memory, in the run gradient descent function, I have one variable, okay? And in the main function, I have another space, another scope, another namespace. Within that scope, I have a variable epoch count. That epoch count within the main function is totally separated from the epoch count in run gradient descent function. So the value 500 is given to the epoch count variable within this run gradient function, and epoch count in the main function has the value 100. Okay, so these two variables are totally independent. So these two definitions, okay, these two will define the definitions of those two functions. So when you execute this code, my Python interpreter will check the syntax of this first function. And if the syntax is fine, it will check the syntax of the main function. And then it will execute this main function. And at that point, the statements inside the main function will be executed. So when you call the main function, epoch count variable will be created within the main function. At this point, the epoch count for run gradient descent function is not created yet. Okay? So it is defined first. That variable, the epoch count of the run gradient descent function, is not defined yet. Okay, it does not exist yet. The epoch count variable within the main function is created with the value 500. And then this print line will be executed. So the epoch count of 100 will be displayed on the screen. And then next print line will be executed to display calling worker is displayed here. And then you call run gradient descent. At that point, Python interpreter will go inside of that function to define epoch count variable for this run gradient descent function. And as I said, this variable is totally independent from epoch count in the main function. So you have two different variables under the same name. I mean, actually, technically speaking, those are defined with different names inside the memory, but for the human beings, two variables seem to have the same names, though. Okay, but anyway, the epoch count variable for the run gradient descent function is created with the value 100. Okay, and then that value is printed. So 500 is printed. When that is done, you go out of the loop and execute these two remaining statements of the main function. When you go out of the run gradient descent function, at that point, this epoch count with value 500 will be erased. Okay? Anyway, the epoch count of the run gradient descent function, when that variable is created or destroyed, those are not related with the variable epoch count of the main function. So when the value is created or destroyed in some other function, this epoch count of the main function still has the value 100. So right after this execution of this function, if you print the value of epoch count within the main function, that value is still 100. Okay? And please note that the variable type of the epoch count is an integer type. Okay? So this epoch count is a variable of type integer. And we know that in case of an integer type variable, it is immutable. Okay? So that epoch count variable was created in two different functions, and that function is integer type, which is one of the immutable type variables. For that variable, okay, I assign different values, and as I said, they are totally unrelated. So when you consider 100 for in one function and then 500 in another function, even right after that variable is destroyed in run gradient descent function, that does not have any effect on the apple count in the main function. So in the main function, apple count still has 100. So that's the situation. So the apple count within the run gradient descent function, the scope is within that function. Apple count defined in the main function, it is the scope is limited to this main function only. So within that main function, I can call that variable. But if you try to print here, if you try to call the print apple count here, then it will cause a problem. It will give you an error message. Okay, so you cannot call certain variable, okay, outside its scope. So in my previous example, so I could use the same name for two different variables, okay, because their scopes were different. So within two different functions, I could define two different variables with the same names, and there's no conflict between these two. So if that's not the case, if I can call any variable in any place, then I need to define many names for the variables. As I said, if you have a very long program, which consists of, say, millions of lines, then you need to name thousands or tens of thousands of variables with all different names. If you build your code alone, that might be, okay, fine. But if you co-work with somebody else's, then they have to define all different names. Otherwise, there will be some conflict, right? So it will be very difficult in that case. So people, okay, constructed this Python so that all the variables will be belonging to certain spaces, namespaces. So, and those variables can be accessible only within that scope. Okay. And if you define any variable within a certain function, then that variable is accessible only within that function. So please be careful. So if I, for example, define a function, say computer BRL gradient function is defined, and within that function, I defined a local error with 0.001. If I call the function, then my Python interpreter will execute those lines, the indented lines inside the computer BRL gradient function. Okay, so calling that variable within that function, say if I call that value, okay, accessing the value within that function is absolutely fine. But if you try to access that variable outside the function, okay, then we get an error. So please be careful, please. So if you are novice to the programming, please be careful with this. So as we observed, you may have exactly same variable name at the same time in two different functions. Okay, and there will be no conflict. And each variable has its own value and memory space. So there is no problem with this. So, as I said, in one function, you can have a variable, say, status, with some statement. In another function, you may have the same variable with different value. So within this run, grow, simulation function, the status has the value of optimizing gradients. But in case of within the main function, the status has the value of idle. So within this main function, if I try to print the value of status, it has the value of idle. If you use the variable status within this run grow simulation, it has the value of optimizing gradients. So these two variables, even though they have the same name, they are defined with different values, and there will be no conflicts with these two. And please note that at this point, I'm using the text string variables, which are also immutable. So in that case, these two variables are defined within this function only, okay? And the values for these two variables are totally independent. But now, when I define the function, we define the function with the keyword def, and that def was typed on the first column without any indentation, right? So we defined a function with the keyword def on the first column of the line without any indentation. And then I just have certain name of the function followed by the parenthesis, followed by the colon with some statements. And then I have another function called the main. With some indented statements as well. So whenever you define some function or variable without any indentation, say if I define a variable c with say value 10, then those functions or the variable c, they are called global variables. Okay, so if you define some functions or variables, okay, without any indentation, so without any indentation, then corresponding functions or variables will be called global functions or global variables or simply global objects. If you define any function or variable like this, then those will be accessible, okay, any place. So if I define function A without any margin or without any indentation, or if I define the main function without any margin on the left-hand side, or if you define certain variable without any indentation, then I can access those functions A or main or the variable C at any place. Those will be called global objects. They can be seen, accessed, or invoked from any place within the code. Okay, so functions is one example. Usually, when I define a function, people usually start with the keyword def without indentation. Okay. In that case, that function will be global, so that I can call the name of the function at any place, even outside the main function. So, for example, here I have the definition of several functions. The first function is named compute BRL residual. The second function is log simulation step. Third function is main. They are all defined without any indentation. That means I can call these functions at any place in your code. I can call those names. So when I execute the main function, the indented lines of the main functions will be executed one by one. So this one will first print certain statements, and then it calls compute BRL residual. So that function is called within the main function. Even though that function is not defined within the main function, I can access that main function because this function is defined as a global object. The next function, log simulation step, is defined outside of the main function, but it is defined without any indentation. So that means that is global object. That means I can call that function at any place, even within this main function. So I can call those two functions, okay, within the main function, even though those two functions are not defined within the main function. If you want, you can define a function within another function. That is fine. Okay? But in this case, those two functions, compute BRL residual and log simulation step, those two functions are defined outside the main function. But since those are defined without any indentation, I can call them inside the main function. So when those two functions are called, the statement corresponding to this definition will be executed. So in the previous code, these two functions were defined globally, meaning without any indentation. Those functions can be called at any place of the code, even inside the main function. So in that sense, those two functions are called global objects. If I define certain variable without any indentation, then that variable is accessible at any place within the code. So if I have these definitions, this print separator function and run grow epoch main function are defined without any indentation. That means these functions are global, meaning those functions can be called at any place. So print separator function is defined outside of this run grow epoch function. Even in that case, I can call that function inside of the run grow epoch function. So I can call these functions, okay, inside of that function. I can call run grow epoch function inside the main function, because all those three functions are global objects. So if you define some variables within a certain function, then that variable will be local. Meaning, if you go outside that function, that variable is meaningless. If you have some variable without, if certain variable is defined without any indentation, then that variable will become global, meaning you can access that variable at any place of your code. So we have some variables which are defined only in some local area. Some variables or functions may be defined globally, meaning those can be used at any place of the code. So please be careful with this scope or namespace. Okay. So here is some example. So suppose that I have three functions, check Los Angeles and check Seoul and main function. Those three are considered. In check Los Angeles function, I defined the smoke level variable with value 45. And say in check Seoul, I have defined a variable called rainfall with a value 12. So if I have those situations, then I can use this smoke level variable only within this check Los Angeles function. So if you try to access their value, that is fine. In case of the rainfall variable, it is defined within this check Seoul function. So if I use that variable within that function, that is fine. But the problem occurs if I try to access, for example, this smoke level variable in the check Seoul function, because this smoke level variable is accessible only within this check Los Angeles function. So that variable is not accessible outside of this function. So if you try to, say, print the value of this smoke level in the check Seoul function, then the Python will complain with some error message. And please note that all these examples, the smoke level, rainfall, or all the variables which were local, were all immutable type variables. Okay? And those are immutable. So far, the integer type or float type or the text strings, they are all immutable type variables. So in this code, smoke level is limited to check Los Angeles function only, and rainfall is limited to only check Seoul function. So they are meaningful in each function only. If you try to use those variables outside, you get an error. So if I define, for example, rainfall variable with the value 85 in the check weather function, and then when I call the check function in some other function, say in main function, that is fine because check weather function is a global object. That is, meaning that is defined without any indentation. So that check weather function can be accessible in any place. So I can call that check weather function inside the main. So the first line of main function is fine. In the next line, we call the print function with certain text string, that is also fine. In the next line, I try to print certain statements with the value of variable rainfall, but that rainfall was not defined within the main function. It was defined within the check weather function. So check weather variable, this weather rainfall variable is called outside the check weather function. So at that point, you get an error. So you see an output from the check weather function or this print line. But when you try to evaluate this rainfall variable in the second print line, you get an error. Okay, so you get an error at that point, and Python will complain with those error messages. And when I define a function, okay, I said it is a self-contained statement, a box of statements. So I said self-contained. So if certain variables are used within the function, those variables somehow predefined before they are used. And if certain values are required, the information must be given from the outside somehow. Okay? And so a well-designed function should act like an isolated processing machine, meaning it should be self-contained, and it takes raw materials from the outside world that will be called input. And then your function will process a certain task, and it may possibly generate some result, and sometimes that result may be given to the outside world. And at that point, that product, okay, which are sent back to the caller will be called the output. And we saw some examples of the input when we call the input function, and we also, that input function generated a certain output, right? And to provide a certain information, we need to provide certain values, a certain information through, by typing their values inside the parenthesis. And if you want to receive some output from the function, then those output must be sent back by using the result function, return function. So let us first consider the input structure. So if your function wants to receive some information from the outside world, from the user or from certain file, you need to define some placeholder for that value. So that placeholder or placeholders must be created when the function is defined. Those placeholders must be defined inside the parenthesis. Those placeholders defined inside the parenthesis will be called parameters. So a parameter is a temporary local variable defined inside the parenthesis. Whenever you have a parameter for that inside the parenthesis, the user must provide an appropriate value for that each parameter, defined in the function. The value provided by the user will be called an argument. So for example, when you call a print function, you provide certain value or values to the print function. Say, if I printed 2 or hello, then those two values are given to the function print. So these two values are called arguments. Okay? In order to receive those values, then there must be two placeholders, one for each value. Those two placeholders must be defined when you define this function print. And those will be defined within this parenthesis. Okay? And those variables defined within this parenthesis will be called the parameters. And as I said, it is one of a local variable, meaning those parameters will exist only within that function. Those temporary local variables are not accessible outside that function. So here is some example. I can define a function as before using the keyword def followed by the name of the function, run diagnostic. Now, in this case, inside this parenthesis, I have certain name. And this name is the name of a certain parameter. I have only single name. So that means I create a function with one parameter. Okay? So model name will be a placeholder, certain value. I do not know whether it is a type integer or character string or whatever. It can be anything. Okay? It will be certain variable. But I will receive one value from the user, okay? And whatever the user is given, certain value is given, that value will be stored under the variable named the model name, okay? And that will be a local variable. In other words, whatever the user provides, the variable model name exists only when that function exists. So this function will perform this task defined by 4 print lines. And then if I call run diagnostic with a certain text string, this pins, this is an argument the user provides. Model name is a parameter, that is a placeholder. This model name, when this function is called with these pins, then that value, pins, will be given to the variable model name. Model name will receive that value from the user, and then it will perform these statements. So when that model name is printed, these pins will be printed on the screen. So when you call this function run diagnostic with pins, these statements will be generated. Okay? And then if I call, and once the 4th lines are printed, you go out of the function, and when you go out of the function, the parameter model name will be destroyed from the memory. So when you print the 4th line right after that point, the variable model name will be erased from the memory. And then when you call this run diagnostic again with a new value BRLv2, my model name variable will be created again with, in this case, a different value, the BRLv2. So when I call that function, those 4 lines will be printed with, in this case, a different value for this model name. Okay? So in this way, I can provide certain information to the function. And at that point, the placeholder model name will be created for a moment. And it exists only when that function exists. Okay. When the last line of the function body was executed, the function will be erased from the memory, and at that point, all the variables created inside the function will be also erased. So that's what happens with this function. Okay, so if I want to create several placeholders, you can define several parameters. Okay, now sometimes you want to do some calculation and then you want to receive the final result from the function. In other words, sometimes you want to generate certain output, and then you want that function, okay, provide that output to the main function somehow, and that operation can be performed using the keyword return. Then whatever the values followed by return will be given to the caller. Okay, so the moment Python hits return statement, the function stops executing instantly, and any lines, okay, and at that point, the values of the expression followed by the return will be given to the caller of that function. Okay, I said the values of the expressions followed by the return will be given to the caller. Okay, and then at that point, right after that operation, the function stops executing, and then the function will be erased from the memory. If you have any more lines after that return statement, those will be discarded. So if you have any lines of code below that return keyword, those will be discarded. Okay. So here is some example. So from now on, the code becomes a little bit complicated. So from now on, some code can be completed within one slide, and some code will be continued on multiple slides. So here I have two functions. One function is compute residual with two parameters. The first parameter is the true val, and the second parameter is named print val with 4 lines. And then I have the main function without any parameter. And then I call the main function. So when I call the main function, it will first print certain line, and then on the next line I have an assignment. So if you have an assignment, you evaluate the right hand side, and final result of the right hand side will be given to the variable appearing on the left, right? So that's what the assignment is doing. So you will evaluate the expressions on the right. So, but on the right of the expression, I have the function call. So I will evaluate this function with 1.0 and 0.82 as the argument values. If I call this function with those two values, then 1.0 will be the argument for the first parameter, and 0.82 will be the argument for the second parameter. So true val will receive 1.0 and print val will receive 0.82. So in that case, true val will be a float variable and print val will be another float variable. The type of the variable will be determined based on the values you provide. So if I provide two float numbers, then the true val and print val will be defined as the float numbers. So 1.0 and 0.82 are given to those variables, and the difference between these two will define the value of residual error. So residual error is another float number, float variable. Once you get this number, I have return statements, return something. So return is followed by one variable. So in that case, this function will return one value. The value of residual error will be returned. If you want to return multiple values, you need to separate those values with commas. But in this case, I have only one variable name, the residual error. So the value of residual error will be given to the caller. That means the difference, 0.18, will replace this expression. So that expression will be replaced by 0.18. So that final result will be given to the variable appearing on the left. So current loss will receive 0.18 value. Okay? And that's at that point, so once this function returns the value, that function will be terminated. That function will be erased from the memory. it does not perform any statements following the return. So these statements will not be executed. So even when you call that function compute residual, this print line is not executed. Okay? So whenever you see the return statement, okay, that's the end of the execution. So you do not see, this will never print on the screen. Okay? And this current loss will be a float type variable because it receives the value 0.18. Okay? So current loss is the float number. So I can add, for example, I can multiply, say, 100 to that value. Okay? And I can even print this. Okay? One thing you need to notice is that my current loss was 0.18. Okay? 0.18. If I multiply 100, the mathematical value will be 18. Okay? 18. But when you print the value of the variable, you see 18 with many zeros, but you see some non-zero value here. Okay? Because inside the computer, every number is represented with zeros and ones. And modern computer, your MacBook Pro, or if you use Apple notebook, the Windows notebooks, so if you use Windows 11, they are operating systems based on double precision. That means every real number is represented with respect to 64 zeros and ones. Only finitely many, 64 zeros and ones represent one real number. So as you can imagine, when you express some numbers in those binary formats, some information will be lost. So even when you have 18, okay, 18, when that 18 as a float number is because initial value of current loss is 0.18. Even when you multiply 100, the final result will be a float number of 18.0. When that float number 18.0 is stored inside your computer, that 8.0 is represented by 64 zeros and ones. And at that point, some information is lost. And then when you convert that value by this print function, okay, there may be some garbage when you represent your value. Okay? So the value from this is this one in this case. And that result may be slightly different if you use a different operating system. So that was the result from my computer using macOS. Okay? But if you are using, say, Windows 11, the output may be different. If we are using, say, Linux, say Debian, the output might be different. The output may be the same in some situation, but it may be different for the operating systems. But anyway, the point is the float numbers may be printed, okay, based on this double precision. And due to this double precision, some information may not be the same. Okay, maybe slightly different like this one. Anyway, that is normal in computer science. So in case of the print function, and print function, it shows some string on the monitor at this point. Okay, and the print function does not return anything, right? So if you use the print on the right hand side of certain assignment statement, it does not receive anything. So the variable will receive none. Okay, and then once that displaying the contents of certain expression, right? So when you call a print function, right after the displaying the contents of a variable, it will execute the next unindented line of statements and so on. So usually print is used to check the values of certain variables, right? But this print function does not return anything. If you want to return something within your custom-made function, you need to use the return statement. So using this return, you can send some information back to the caller. Okay. Yes, and in case of the input, so we considered inputs and outputs. So in case of the input, if you want to provide some information from the user to the inside of the function, we need to use the usage of the parameters. I mean, you need to define the parameters to define the placeholders for certain variables. And then you need to provide appropriate information to the function whenever that function is called. Okay. So, there are some examples. So these are some examples. So if I consider, say, round function, we didn't consider this round function yet, right? But there is a function called round function. And if you want to use that round function, you need to provide two numbers. One, the value which need to be rounded. And one more number to define the precision. Then, this number 2 will define, okay, where that rounding will be considered. So 2 means I want to consider this rounding of the number in the second place below the decimal point. Okay? And so the round function is designed to handle numerical precision in the expected two specific inputs to perform its tasks. And the first argument is the number you want to consider the rounding. And the second argument is the decimal precision. That means I want to consider the rounding in the second place. In case of the len function, you need to call the len function with one variable, not two, right? So that means len function was defined with only one placeholder. One parameter inside the parentheses. So whenever this len function is called, I need to provide one value, one variable. Okay? It accepts certain character string, for example, say Python. Then len will count the number of elements in that text string. But I can even call the len function with, say, a list variable. Then it will count the number of top-level items. So those can be considered, right? So if I define certain function with some parameters, then whenever I call that function, I need to provide the same number of values. Then the first argument will go to the first placeholder, second argument will go to the second parameter, and so on. So when I have this definition, format simulation data with the two parameters, then whenever that function is needed, I need to provide two values, two arguments. One for the row value, second number for the decimal points. Okay? When those two arguments are provided, inside of the function, you can manipulate those variables. And as I said, those parameters are local variables. So there are two ways to define local variables. You can explicitly define those local variables like this. Or you can create local variables using parameters. They are all local variables. They are local in the sense that they can be used only within this function body. If you try to access those variables outside the function, you get an error. And their values will be accessible only within the function. Once the function is destroyed, the function is destroyed from the memory, either you reach the end of the statements or if you face the return keyword. So in that case, okay, those temporary variables will be erased. So if I call that function with, say, values, these two numbers, then you see some output. If I call that function with different values, then you get different output. So that's what happens. So here is one example. So suppose that I have, say, DEF definition of calculus of, say, two variables, A and B. Okay? And then I want to print the A plus the B. And then if I call this function with the value 10 and 20, on the screen you get 30. When two values are provided, A and B will be defined as integer variables with numbers 10 and 20 each. And then when you add this, you get 30. If I call that function with, say, the character string A and B, in that case, my temporary variables A and B will be defined with text string. And in that case, the plus sign will concatenate these two variables. And on your screen, you will see just AB, the text string of AB. Okay? There is no problem with this structure or the code. If I call calc of, and then if I provide 10 and the text A, then at that point you get an error. You get several lines of error messages. Okay? So, this, when you define certain function, okay, you get the Python interpreter will adjust the syntax only. The behavior might be different depending on the values of the arguments. Okay, it doesn't matter. Okay, as long as the syntax is fine, Python interpreter does not complain with the syntax. Okay, and when you call the function, at that point, the Python interpreter will evaluate each line of the statements, and then it will check whether everything is fine. Okay? So that's the case of this print. Now, if I consider the similar function and say AB, and then if I return A plus B, and in that case, if I call this if I call this calculus function with the value 10 and 20, if that's the case, then this 10 plus 20 will be executed within this calc function, but that is returned by the function, but that value is not received by any other variable. So that value will be computed and returned by the function calc, okay, but there is no receiver. So on your screen, you don't see anything. Okay, that's the situation. If I have print calc of 10 and 20, then at that point, the value 30 will be displayed on the screen. Okay? If I define S with the value of calc of this, then if I have print S, then this variable S will receive the value 30, and 30 will be displayed on the screen. Okay? So in this case, my function returns one value. If you want to return multiple values, you need to separate them with a comma. Then, on the left-hand side of the equality, you may have, say, two variables. Then S variable will receive the value for this A plus B, and the next variable will receive the next returned value. So in this structure, S receives the value of A plus B, and T receives the value of A. So when you print S will be 30. So 30 will be displayed. And if you print, say, T, then additional value will be displayed on the screen. Anyway, let me continue a little bit more tomorrow regarding these functions. Okay? Questions? Okay, then let's call it a day and see you tomorrow.